Okay, so that's doing its thing. And we'll go to our class. All right, let's shrink that just a little bit. It's probably good enough. All right, so today's topic is databases, and this is the first of several discussions on that topic, and introduction to Pandas, which is a external package that allows manipulation of databases. Those of you who can count and read will notice that we've gone from lesson 9 to 11. Now, I'm aware of that. That happens to be on purpose because lesson 10 is not complete, and it is unlikely to be completed this semester. Barring a global killer satellite slapping into the earth, I have no time to actually get it done. So if you really want to see lesson 10, simply fail this class and you get another shot at it. But I don't recommend that. That's just a no-win situation for everyone. Or you can go look here and see what it was, but didn't have time to get it all done. So today's goal is to understand ultimately the abstraction called a data frame, and you'll actually get that in lab because based on this morning's progress, I didn't get very far. Be able to access and manipulate data within a data frame using, in our case, the Pandas tools, and be able to obtain basic statistical measures of data within a data frame. So some of those statistical measures are the average of things, the variance of things, how many things, that kind of basic statistical measures. You don't actually have to take the class in statistics and be introduced to funny letters of the Greek alphabet that make absolutely no sense in the real world. The main computational thinking concepts of databases are abstraction and decomposition. So as a funny visual aid here, here's an automobile that has experienced dramatic decomposition. And if we wanted to be sure that that particular car was all there, a database would be a handy tool, presuming that the database would know where each and every part is supposed to be located and could identify if a part is missing. And then we would no longer be dependent on the very poor shading here to take out a driver's side quarter panel and the right rear wheel. Although those two are pretty big parts as parts go on a car. So it might be obvious that those are missing. But somewhere in that array of parts are bearings, and the only way you find that out is when you pick up the subassembly to put it back in the car, and you hear that sad sound of tink, 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 tink. Anyone here ever heard that when they worked on a car? Do y'all even work on cars in high school anymore, or is that just like an old timer dude thing? Oh, that's a damn shame.
Sometimes
Really? Really, I don't do it?
there's a few different high schools.
Damn,
The
that's
majority of them.
that's probably because people can get hurt and the school can get sued and the principal can't drink their mint juleps in their office or whatever principals do. So the idea of a database is if we have the location of each part and it's recorded somehow, a database being one way of recording where everything is, we can determine if something is missing as in the second picture. On the other hand, if we had two fully assembled cars, only a fool would take them apart that far. And we moved them and then heard that tink, tink, tink of a ball bearing, we'd know something is missing. And again, if the database had access to all the locations of the parts, a simple interrogation of the database, and the word we use for interrogation in database is query, we'll find where all the balls are supposed to be and help us figure out which car is incomplete. Now, another context, you don't necessarily want to have to take the car apart to store every piece separately whenever you park it in the garage. Although in some places, if you park the car, it will self-disassemble overnight. I'm thinking the south parking lot at the Harlingen Airport. I'm sure that rental car was disassembled and transported to a nation south of the US and reassembled and put to good use. In that case, you want to store the entire car as a single entry in the database and access as pieces if necessary through the entity called the car and then the individual piece within the car. And used car parts are normally stored in that way. Instead of taking a car apart, putting all the little parts in bins, which would be easy from the front office point of view of selling the parts, you just leave the car whole in the back and let it slowly rust away. And if fools like me come with a 30-year-old car and need a part, they hand you a wrench and you go take the part off it yourself. And naturally, the part you're looking for is what everyone else wanted too, so it's unfindable. It's not just cars and high schools where you reassemble cars, but I guess you don't do that anymore because y'all just told me you didn't. But if you want to do something like that, you can't go back to high school, but you can go into the United States Air Force. And if you're lucky enough, they'll send you to Davis Moynihan Air Force Base somewhere in Arizona. And they picked that location for a good reason, because the name of the state should be Arid Zona, and stuff doesn't rot. So those are pictures of Boeing 707s that were disguised as B-52s and painted green, and they're chopped up. The chopping up has nothing to do with database, has to do with the treaty that the United States signed with the Soviet Union at the time. So it was Strategic Arms Limitation Talk. I think it was SALT II. And the United States, we had to tear up a bunch of airplanes, but we're not as stupid as the rest of the world thinks we are. We broke the airplanes. Okay, those things aren't going to fly again. I assure you, a talented welder with a MIG welder could reassemble those things and get them serviceable again. Yeah, we get Elizabeth there, and she'd have those things flying in no time. And then that's the proper amount of self-confidence to have. But we still do operate 80 of them as a country. Boeing hasn't built a B-52 originally for, I think the last ones were built in 1959. They're as old as I am. That's kind of pitiful. They're in good shape and I'm falling apart. So, to keep something like that flying, parts break. So where do you think they go get the replacement parts? They don't 3D print them. They go out there and they send some poor sucker with a talented welder. And in this case, she cuts the part out, cuts everything around it, and they ship the part to whatever plane needs it. So how does the Air Force know that there's parts out there in the desert? Do they guess, or do they go, we're the Air Force and we pay $600 for hammers, so there must be a few spare parts out there? Or do they have a database? They have a database. They obviously, if it's in the database lesson, it probably has something to do it. Occasionally, they have to grab a whole airframe. And I want you to point out the date on this photo. So January 21st, 2022 was, it's like, today's the 16th, add another 20 days ago, less than a month ago, your first conjecture was correct. And so that's being dragged up to Oklahoma City because Boeing got a contract to do modernization, which is more than just painting pretty pictures. And they needed a test case to do it. So they decided to use the particular airframe, which was originally serialized in 1955 and is affectionately known as Damage Incorporated 2. So at that particular, the photo was taken in Tucson, Arizona, making its way through the central US on the way to Oklahoma. That would be a really weird thing to encounter on the interstate. Because you know how long those things are. I mean, they're as long as a 777-ish, give or take. So, the truck driver's not going no 40 miles an hour. He's going as fast as he can. So you gotta be hitting 100 by the time you get past his rear bogey wheels to be able to get that around that thing in time. So databases have utility. And if you're not into airplanes or flying stuff, but since I got the two NASA people, because you're all taking turns wearing your NASA paraphernalia, which is cool. Figured something that flies would be interesting to you. Of course, you're robots, so you want to get the stuff there on Mars and go poking around and looking at the rocks. So databases in their simplest form are simply containers for data. We've already seen containers for data. Probably the most likely container that you would come if it appeared on a multiple guess question on your next exam would be, which of the following Python data structures makes a good container for data? Actually, they list the Python data structures that would make a good container for data. And that list, you would say list or dictionary. You could even get away with tuple, although that would be a piss poor container for data, because 2 of the 4 things that you do with databases you can't do. So public library stores books. There's that big building over there called the library. Most of you have probably never been in it. That's okay. We have the internet. It is a database for books. But strictly defined, databases refer to computer structures that save, organize, protect, and deliver data. And the system that does that is called a database management system, or DBMS for short. One thing particularly important about databases is that word protect. They are designed to make data extremely difficult to destroy. And if you all leave here and you get a contract working for the federal government building databases, it will be imperative that the data never disappears. So for example, if you get on the no-fly list by accident, you'll never get off it. You'll get a redress number, so they'll still let you spend money and fly an airplane down in the back end of the airplane while you clean out the toilets in flight, but you'll never get off the database. If you get audited by the IRS once in your life, like when you're 23, you get audited every year thereafter. All because of a screw up in a database when I was 23 years old. I didn't make much money when I was 23. That's when I was still selling marijuana in Northern California, and it was seriously illegal. Oh, I didn't say that in the recording, did I? And I don't think that had anything to do with getting on the IRS audit database. So once you get audited, hopefully you have good financial advisors that tell you, well, you just get used to that. And so well, it doesn't happen in April because I do extensions every year now. Since I know I'm going to get audited, might as well at least delay the paying for 6 months. So that is the part of database that we tell you theoretically can't be done. Data in a database is never destroyed. There's a reason Amazon and Google and Microsoft and IBM keep having to add server racks to their server centers, because they don't throw any data away. Oh, that being said, let's move on. A database is an electronic filing cabinet. I guess that's as good a mental model as any. And the data itself is kept in persistent storage. So in principle, we're supposed to be able, as users of a database, put new information into it, delete, change, or retrieve existing information, with my aforementioned warning on the inability to actually really delete stuff. Normally, when you're doing it in a practice sense, you're always operating on a copy of the original database, and the synchronization of the copy to the actual backend database happens once a day at some weird hour, like 3:27 in the morning. So for example, imagine the Amazon database that has on every one of you. Is there anyone in this room who has never purchased anything from Amazon in their own name? Okay, one of you. So you're the only one who is off the grid as far as Amazon is concerned. The rest of us are occupying portions of their database. That thing gets backed up, probably not every night, probably 4 times a day. You can imagine how long it takes it to do that, even at the speed of light. And the electrons in this are not moving at the speed of light. So my 2 NASA people, how fast are the electrons moving in my computer? 99%. I think like 6 or 7 tenths the speed of light. That's why it's getting so damn hot, you know?
That's not the electrons, actually. It's more like the motor of a fan. And like the.
Where do you think the heat comes from?
Not The prosecuted, yes.
I mean, so you look at your computer and you think, why do these things break so often? They got hardly any moving parts. I submit to you, they have billions of moving parts. They're just real little teeny parts. Okay, so in any event, normally we're operating on copies of a database. And in practice, those user requests to a database are formulated in a variety of different ways. The best for you at an endpoint of view would be by pointing and using a clicky doodle. But generally, it's more convenient to assume that that query is in the form of a simple text string in some formal language. And as for example, if we had a human resources database, we might submit an instruction to the database that looks something like EMP, where job equals quote programmer, and that expression represents a retrieval request. In general, all commands to a database are called queries. And I guess you could argue our Jupyter notebooks are a kind of a database. And when we type a command in a code cell, we're generating a query to the Jupyter kernel that interprets it as a Python language. So for example, that expression is look in the database called employee, find everyone whose job title is programmer, and then presumably it returns some information back. So the query itself, the submission of the query, and the response is called a transaction. Good databases have successful transactions approaching 100% of the time. Home-built databases don't necessarily work so good. The types of databases, there's two major types that you will encounter in your near future. One is called a flat file database, and we'll describe that shortly. The other is relational. So the simplest form of database is a text database. So how many people in here have used a text database? You got to pay attention for a second. Okay, how many people have one of these things? This is known as a taxpayer location device, a TLD. Everybody in here has a TLD? Pretty much, yeah. And unless you have absolutely zero friends on this planet, which even the most introverted, creepy human being has more than zero friends, you probably have their name and phone number in your taxpayer location device. That is a flat file database. And then you access it by pressing buttons on it, and usually it will call them at an inopportune time, and you'll realize that you have made that database transaction erroneously, and you have to follow it up with a rapid text. Oops, sorry, butt dialed you, dude, or something to that effect. Oh, I guess that just happens to old people. Okay, so that's an example of what would be a flat file database. Your contacts database in your phone is not a terribly complicated database. Last name, first name, phone number, home phone number, email, any special notes, and I'll leave that all for your filthy little brains to interpret what those might be. So we go to another level of database called relational databases. And a relational database is comprised of multiple collections of those flat file databases. So maybe your contacts list, I don't have another good phone metaphor, so never mind. Where you have multiple tables of information and they only share certain parts that are common. And it turns out that that's actually a fairly efficient way of storing and retrieving data. So at that point, relational database management systems, which go by the acronym RDMS, or maybe RDBMS. I think RDMS is, I copied this stuff from somewhere. So I have RDBMS in a different part. So wherever I copied it from, obviously two different locations. Examples of relational database systems: SQL Server, MySQL, Oracle Database, Sybase, Informix, and there's a German one, I forget what they were called, Systat, and it doesn't matter. They all more or less, under the hood, kind of work the same way. The way you access those databases is through something called a structured query language. And structured query language, unlike Python, or COBOL or Fortran or C or C++. It is somewhat unique to whatever the backend database is. But a structured query language query will look the same to us as users. So we would be able to interpret what the query is, even if we don't know the exact syntax. Kind of like our Python scripts, except the orange box of encouragement only comes when it matters. So an SQL query, the usual structure is you have to tell the management system what database you want to query, which schema you want to query, which table you're looking for in the database, what field, and then what to do. Return it, change it, make it take the square root of the number of legs on a cat. It's 2, by the way. And so those tables themselves are like spreadsheets or any other flat file structures. And then the collection of tables makes up what's called a schema. And then the collection of schemas creates a database. So for example, let's do our phone call database, and then it keeps, and then you have the same names and you have the swipe right or swipe left on your Tinder account database. 2 separate files. The schema is both, and you can use that to associate certain features of both. There's some emergent structures called NoSQL and direct. I don't know what any of that is, so we'll skip it. So here's a relational database toy example. So in the picture up on the screen, we have 3 tables. We have one table called S, another one called P, and another one called SP. The S table represents suppliers under contract for something. And in this case, the S database has a supplier number field, a supplier name field, supplier status field, and a city field. Each row of the table, except the first one, which is just column headings, is called a record. Each record is comprised of fields. So our next database, the P database, is the parts database. So this is a very interesting company. They make whatever they make using nuts, bolts, 2 screws, a cam, and a cog. And so those are the various parts, parts 1 through 6. So the parts table has part number, part name, color, weight, and city. And then the actual orders is the SP table. So for example, it tells us that supplier number 1 is providing part number 1, and it's sending 300 of them. So if you want to know where those 300 part number 1s were coming from, where do they come from according to that database? Ask you, the human being, to figure that out. So part number 1, well, in the parts database, those are coming from London, and supplier 1 happens to be London, so that kind of makes sense. Let's suppose that was the database we wanted to build our own data frame structure, and we had never heard about pandas or data frames or seen Excel, but somehow we knew Python. Go figure. Probability of that is about as close to 0 as you can get. As close to the same probability as a great white shark shuffling in through that door and biting me in the butt. If that happens, by the way, get video of it, please, because that would be
Hilarious.
that, not for me, but it would be worth it. Yeah, it would make the rest of the internet happy. It would make their day. So here is our attempt to illustrate what database management looks like. So we have a list called parts. That corresponds to which of the tables up here? Use your principle of algebraic substitution at this point. What happens when your bladder's full? You have to, good, it's the P table, excellent. We have a suppliers table, which corresponds to the S, and finally the SP table, which is called the shipments table in this case. So this list construction is exactly a Python list representation of those 3 tables. There's nothing there that you haven't seen before. Conceptually, you may not have seen those particular letters of the alphabet in that order, but conceptually, that's just 3 lists. One list is called parts, one is called suppliers, one is called shipments. Now let's examine some things. So each of those tables, there's columns. Those are called fields. There's also rows. Each of the rows is called a record. There's also hidden from view a unique record identifier for each record in each table. For example, the first data row of the parts table has a unique record identifier, which is basically its position index. It has a number 1 associated with it. Well, you argue, well, that's not unique because the suppliers one also has a number 1 row. And I agree with you. Indeed, they do. But parts square bracket 1 and suppliers square bracket 1 are different than each other. The contents of them are going to be different, always. Well, maybe not always, but the contents are different. So now let's query our little toy database. Let's suppose we want to know all the parts whose weight is less than 13. Now, I admit that anyone in their right mind would go, I'm not going to write a computer program for that. I'm going to look at that table. There's only 6 parts. I ought to be able to find stuff that's smaller than 13. Looks like part 1, a red nut, is smaller than 13. And part 5, a blue cam, is also smaller than 13. Look at that, red and blue, all the states of the United States represented in colors. But let's go ahead and use that as our test case, and we'll build our query. And the things we have to do in our Python script are identical to what an actual database management system has to do. We have to select the right table. In our case, we do that by actually selecting the correct list. We have to construct a search and find all the instances of a part with weight less than 13. In our case, we want to print out the results. So here we go. And I'm not going to run this live because we don't need it. We can do it off of Memorex right here. Oh, this is happening again. I can't operate a computer. You know what's funny is when I touch your guys' computers, I destroy entire directories. When I touch mine, I just get blue flashes everywhere. So first, for I in range 1 to however long parts is, that's our first part of our query. So where are we identifying the table? Is parts. Why are we starting our search at 1 instead of 0? Yeah, 0 is the headers. The first row usually contains header information. Not always, but usually. As we're searching through the parts database, if you will, we're going through its entire thing, and we're making the test if whatever row we're in, field number 3, which corresponds to the 4th column, if that happens to be less than 13, go ahead and print it. Otherwise, keep going. That's all that query says. And when we get done, we get the 2 rows back. Okay, so that was cool, but let's modify our query. Let's say I don't care what the part number is or what the part name is. I just want to know, let me take that back. I don't care what the weight is. I simply want to know the part number, color, and city. So again, to build our query, we have to pick the right table. We have to construct a search to find all instances of the parts with weight less than 13, and then we will print the slice of the list with the requisite information. Now, alternatively, we could have taken this first query, sent that to a new table, and then done our second query on the new table. That'd be a little faster if these tables are really big. But for the toy problem, again, it's not too hard. We select our, oh, no, it's not going to work at all. Fine. Silly machine. We select our list that we're going to search. We're going to search through all elements of the list except the 0th element, because that's a header row. There's nothing to see there. We're going to test by row, by field positional indicator 3. If it's less than 13, that's the weight field. And then we're going to print from that particular row the part number, part color, and part name, I think. Anyway, a sub list. and we get the part number, the color, and the city. Now let's suppose we want to modify the contents of the table. Let's suppose that we have gone up to the boardroom level and made a corporate decision that all suppliers with a status of less than 10, we're going to terminate their contracts. So to do that, when we terminate their contracts, the remaining suppliers will go, well, we want some special dispensation. That's money you're not having to pay them. We want the money. So we'll elevate their status by 5 or some silly business like that. So again, we have to select the right table. We have to construct a search. In this case, we're going to select the suppliers table. We're going to search for status equal to 10. If it's not equal to 10, then we're going to copy the row and store it in some temporary place. If it is equal to 10, we will skip it. And then when we're done, we take that temporary copy of the table and we stuff it back to its original location and rename it. So now our query in our homebrew script is starting to get a little bit more complicated, but no single part, interesting pun right there, is too difficult. So we have this list called temp. That's just to store stuff temporarily. And we make our search through suppliers. If the status category is equal to 10, we're going to skip over that supplier. Otherwise, we're going to append to the temporary storage the entire supplier row. And then finally, we will, when we get done, we will take the contents of temp and put it back in suppliers, which will have the effect of clobbering the original list. And then we'll go ahead and print it. So sure enough, we start out with our original list. And I think Jones is the one who gets nuked. We don't need 2 people in Paris because they're all parasitic anyway. And so we do that and remove Jones. Thank you. Were you grinning at my piss poor pun?
I'm approving, I guess, deep down I'm approving.
Okay, approving the removal of parasites.
Good idea.
And so now what we have left are just these 4 suppliers. Now suppose we wanted to find out how many parts were coming from London. Again, our query gets a little more complex, but still manageable. We would have to use our vast scripting skills that we have amassed in the last 6 weeks. And again, parse or read the supplier list, and then keep count of how many shipments come from a particular supplier, and finally print that, and we find out that, see, all the London suppliers added together are shipping 2,200 parts. So that's probably pretty obvious really quickly for any of you that are still paying attention and have not gone into the rabbit hole of the mighty internet, that writing our own database management systems, except in very specific cases, is kind of dumb. Because every time we get a new database, we're back to rewriting scripts again. It's job security if you like doing that, but it's not the brightest thing to do. So instead of writing our own scripts that are unique to each database and actually technically each schema, the Python community, so a bunch of snakes got together and they coiled and wrapped around each other into a snake ball, created a module called Pandas. And it got its name because most things in the world are manufactured in China, and their national critter is the panda bear. So that's why they called their database management system Pandas. No, actually, it's a contraction of the panel data structure or something close to that. That's where Pandas, the name comes from. I kind of like the panda bear analogy better myself, because that statement is pretty much true. Most things in the world are made in China, and their national critter is a panda bear. So there's just nothing wrong with that. So we're going to look at the Pandas module briefly here, and you'll see it more in the next couple of labs. Josh will run you through some Panda motions, or as we call it, pandemoniums. So first thing, installing Panda. For those of you that have functioning Anaconda installs, Pandas should be simply available to you by the miracle of the keyword import, followed with a space, and followed with the word Panda. Run it, and it should just sit there and likely do nothing, rather than give you the pink screen of frustration. If you are a Linux person like me, unfortunately, you have a little bit more work to do. And that's why I'm not demonstrating it, because I have no idea if it's installed on my server. I know it works. I'll go on the deployment server. Hopefully the automatic login will work. Sweet. And actually, this is lesson 11. Let's just, so lesson 11 used to be 10. That looks about right. So we will find out if I have Pandemonium running. Somewhere down here, we do Pandas. So there's the Pandas module. There's lots of words about it. Pandas is the core library, blah, blah, blah. You can read that on your own. The data structure is called a data frame. That's a key abstraction in the Pandas module. The data frame itself looks like that picture. It is conceptualized just like a sheet, a tab sheet in a spreadsheet. So if you've used Excel or Lotus 123 or Quattro Pro or Numbers, or see what's the, I think those are all the, oh, and then VisiCalc, the first spreadsheet. That was back when computers had vacuum tubes and none of you all were birthed yet. So spreadsheet, rows, columns. The top row is called the header row, so named that if you apply the French Revolution function to it, it completely removes the head and it goes toppling off in a bucket. The leftmost column is called the index column. And then the actual data is stored in this part of the data frame. Now the data frame internally is probably not represented this way. It's probably done in a hash table, but that's our mental abstraction for a data frame. So to set up the modules, this was, let's see, I'm running the Python 3 kernel on an Amazon Web Services server in West Virginia. What are the odds? Mountain Mama, take me home, country road. So if you get that picture, that shouldn't happen to any of you all. You have to go through this rigmarole right here. And I'm not a super user right now, so I'm going to do something fundamentally sneaky, switch to the Python 38 kernel, which I'm pretty sure has Pandas installed. Sure enough, that's what should happen. Nothing, or the appearance of nothing. And then we can test our conjecture by just a simple one. So we have a data frame called parts. And let's see if parts is actually in the, I think parts are parts is going to be the data frame that I actually want. So let me go back up here. That was a good yawn for somebody. That's because you're tired. It's in the afternoon, right? Your blood sugar is plummeting low. It's not because of my seemingly boring talk about pandas and data frames. Okay, so what you just watched me do is I scrolled back up to our toy database and created the 3 tables. So I have a table named parts now, and I'm going to go ahead and use the pandas.dataframe method, which will convert parts into a data frame. And we're going to name that data frame parts DF because I have absolutely no creativity in naming. And then in the parts data frame, we'll set the axis, the 0 axis, and do an in-place replacement to label the columns. And then we're going to drop our first row. So that's going to get the names right. So let me just take a look at so there's what parts looks like right now. That's just a list. So what I want to do is I want to grab this first line and declare that in the data frame structure, the column headers, and I want to insert an axis row here to keep track of the lines of the database. And that's what those 4 lines accomplish. And there's my parts database. Similarly for suppliers, do that. And for shipments, we do that. So those are identical tables to what we had before. Now, shipments data frame and shipments list are different structures in the kernel. Let's suppose I want to know what the shape of the parts data frame is. I mean, I know it's a rectangular array of some kind, but I want to know how many rows, how many columns. So the easiest thing to do is to type parts data frame dot shape, because once it's created into a Pandas data frame, there's a lot of methods that are associated with that particular class. So once something is a data frame, there's a lot of methods that come with it being a data frame. So it tells me it's 6 rows by 5 columns. Let's see if that makes sense. We'll go up and look at a picture of it. See, the parts one is 6 rows, column 1, 2, 3, 4, 5. Sure enough, the computer's doing it right. Supplier shape is 5 by 4. Shipment shape is 12 by 3. We want to select a single column of the parts data frame. Remember how we would have had to do that in the actual list. If we wanted to print a single column of the actual list, we would have to go for I in blah, blah, length of the list, print the correct column and run through that loop. Or with Pandas, we simply type the name of the data frame, the name of the table, and what we want it to list. In this case, the key color. And sure enough, it tells us what that column is. So that is certainly an economy of coding right there by using Pandas. We also can select using the location function, or I guess location method that's built into a data frame that comes by virtue of a data frame coming into existence. In this case, we're going to use the location method. We want to locate position 5 and 6. And notice that that is a list, 5, 6, and it's only one list. So it's going to find the row 5 and the row 6 element of the data frame. So I do that. Now, if instead, I think I get the syntax right. I always screw this up, and that's a good thing because it lets you know that even your instructors aren't particularly brilliant. I wonder if I can do it on key. I think I can do it based on a key. If not, I'll go back and do it the way. Let's suppose we just want the color. Now my location function has the 0 axis, which is the row, and the 1 axis, which I'm using the key color. And so 2 things will happen here. Either we'll get the pink box of stupidity, or we will get exactly what we wanted. So the location feature is really pretty handy. Axis 0, axis 1. By default, axis 0 is the row. Axis 1 is the color. Let's suppose we wanted to get the color and the city. We just enclose those in a list. We can have city. Yeah, it does. And provide the keys. Close that in a list. Use the right delimiter. So that should produce 5, 6, blue, red, and London, Paris. Sure enough, well, Paris, London in this case. All right, continuing on with the demo in 1 minute or less. We also can do conditional selection. That's actually a real powerful tool of Pandas, because doing that condition in a classic MySQL database, the query is a little bit cluttered looking. It's the same intellectual thinking, but the actual query is cluttered looking. So, but take a look at what this is doing. So in the parts data frame, we want to search within the parts data frame for the weights, and we want to return all the values that are less than 13 associated with weight. So it's going to return the rows that have weight less than 13. This is a hard part, at least it was for me to get my brain wrapped around, is that the name of the data frame has to appear twice. Because the first one, the outer one, is you're identifying what table you're operating on. The inner one is the actual query that you're asking of that particular data frame. Run that, let it rip, and sure enough, we get the parts that we're looking for. Okay, so judging by the sound of everybody packing up and I hear all your brains clicking off, I'm going to assume it's time for me to stop and mosey on over to my office so that we can have lab. Well, Josh is going to begin again. I have a date, so I'm going to blow you all off as soon as the recording started. He'll go through a lot of these things. We're going to spend 3 lessons on this topic, so you should be able to pick up Pandas by next week, no problem. All right, well, thank you for your attention and patience and laughing at my crummy puns.
Do you want me to turn in the part of the text I emailed you to Blackboard too? Or no? Like the coding part.
Yes, please. See if it'll let you upload it. If it doesn't, don't worry about it.
Okay, I think it probably.
I had a quick question about the homework. So whenever it asks about the shape, does that mean like the length or like the dimensions of it?
Yeah.
Okay, and then another question is on the last part, the combining the 2 matrices and like finding the multiplication. It keeps popping up with this